Okay, picking up where we left off on topic 8B-1, we moved on to slide page, we call them slides, so used to the PowerPoint. Page 6 of the PDF. Okay, number 1. Yeah, we're going to run through these 6, and then you'll have a whole batch of questions just for practice. I'll craft an independent assignment. Again, if you have questions on those slides, message me and I'll add them to the list, and I'll work a handful of them out over a couple of days. All right. So number 1, given a rhombus. Given a rhombus, since all 4 sides are congruent. We don't want to assume that it's a square because we don't know that the angles are all right angles. Okay. And so anyway, let's just kind of do this. Let's see, right there. Yeah, I know the compass is, or the protractor's right there, but fine. Get. Okay. So T, U, V, and S. Okay. It's a rhombus, 4 congruent sides, so we know that the diagonals bisect each other and they are perpendicular. So let's add some information to our little picture here. Congruent. All right. So we look at what we know. So we have the picture, and it's kind of tucked away in the corner on the page there. We are also told that TV is equal to 16 yards and SU is equal to 9 yards. So let's start with the area, since we have the length of the diagonals. TV, diagonal 1, SU, diagonal 2. And kites and rhombuses share the same formula for area. Let's use this space over here. The area is 1/2 diagonal 1 times diagonal 2. Doesn't matter which one's 1 or 2. The answer is going to be the same in the end. 16 times 9 gives us 144. So 144 times 1/2, which is the same as 144 divided by 2, gives us 72 square yards. So there we go, we got the area. So let's divide. Okay. Now the perimeter. Again, you might say, well, we can't do anything about the perimeter. I don't have the side. Not the case. Since we know that the diagonals bisect each other by properties of parallelograms, we know that from U to this point here, and let's just call it C for center, is half of SU, and CV is half of TV. So UC is half of 9. 9 divided by 2 gives us 4.5 yards. And CV, half of 16, which is 8. So that's to include the figure here. Remember, the reason we're able to find that missing side is because the diagonals bisect each other and they are perpendicular, creating a right triangle, which gives us all the information we need to find the length of one side. And since all the sides are congruent, one side is all we need. We take that one side and we're going to multiply it by 4. And that's going to give us our perimeter. Alright, so UC, that's our 4.5. CV is our 8. And then our hypotenuse is the length of the side, UV. So S for side. Alright, so Pythagorean Theorem. A squared plus B squared equals C squared. So the two legs, 4.5 squared plus 8 squared is equal to S squared. So 4.5 to the second power, 20.25 plus 64 is equal to S squared. So 84.25 is equal to S squared. That is a 5, not an S. Final step here, take the square root of both sides. Square root and the square cancel out. Simply, so 9.17, 8779875. Now we could round now. Like it's a bit of a crossroads here for me personally. I would say, just since we know this is the length of the side, just take this number and multiply it by 4. And then, given the circumstances, provide some leeway. If you want to round to the nearest tenth, so we can round this to 9.2, and then multiply by 4. So we'll do it both ways. And we can use the whole thing. So the S is equal to 9.178779875. So again, since this represents the side length, and the perimeter for let's put it over here, perimeter is equal to 4 times the side length. Since all 4 sides are congruent, just multiply the side length by 4, and that gives us your solution, the perimeter. So if, so sometimes rounding now or at the end you get the same answer, but other times you don't, which is why I always suggest you exercise caution. So if we round now, then we end up with 4 times, it says round to the nearest tenth, so 9.2. So let's see, 4 times 9.2 gives us 36.8 yards. If we use the whole thing, we actually end up with the same thing. Let's just do it anyway. So 4 times 9.178779875. Oof, ran out of space there. So multiply that whole thing by 4. We end up with 36 points. Oh, actually, no, we don't. I thought we did. 36.7151195. So we actually end up with 36.7. All right. Yeah, no. So I guess technically my solution on the PDF is incorrect. Like I said, given the circumstances, I'm gonna try to loosen up on some things here. Yeah, so let's see, technically different answers. Quizzes and tests, not so much, just throwing that out there. Okay, so that's number 1. Let's proceed. Put them on that side. I try to make the most of all this paper. Okay, so we'll on to number 2. I want to go by pretty quick. We have a triangle. I say that, but it doesn't always work out that way. given a triangle looks kind of like this. And you say, well, there's, I don't have the base and the height. These two sides are not perpendicular to one another, so I can't do anything about it. But remember, we also have that second formula. For perimeter, here we're not going to be able to do anything about that because we didn't cover the formula that would help us find this missing side. Since that was not part of the EOC, I'm not going to cover it now. That'd be a whole different lesson all on its own. So we're just going to roll with, we don't have enough information to find that missing side. Perimeter, no dice, not applicable, can't figure it out. The area, we have the formula 1/2 B times C times the sine. And we change the variable to D so we don't confuse the two A's, times the sine of D. That we meet the criteria. We have the two sides. Let's emphasize them with blue. The two sides and the included angle. So remember, we know that we have the side angle side pattern because the two sides intersect at the vertex. That gives us the angle. So side, angle, side. Now we just plug in everything where it belongs. B and C, interchangeable. 8 times 6, 6 times 8, you're going to get the same thing. So 1/2, 6 times 8, times the sine of 153. 6 times 8 gives us 48. Sine of 153 gives us 0.453995. Take that number, multiply it by 48. 21.79154399. Divide that by 2. And we get 10.89577,199, rounding to the nearest tenth. Approximately 10.9. For the sake of it, what if we'd rounded right here to the nearest tenth? Well, then that would have been, again, just for the sake of seeing the differences in when we round, difference in solutions depending on when we round. If we round before the very end, nearest tenth, 21.8. Divide that by 2. Well, unlike the previous problem, this one, we ended up with the same solution in both cases. So again, sometimes it doesn't matter when you round, other times it does. And so that's question number 2, page 6 of topic 8B-1. Moving on to question, we're going to skip question 3 because question 3 was just like question 2 from the previous slide. So if you can do question 2, you should be able to do question 3. For that matter, let's skip question 4 as well. That's a rectangle, and that's too easy. Yeah, that was too easy. Just give me that one. Let's go to number 5 though. There's a tricky one. It's a regular polygon, but we do not have the apothem. So what do we do? I'm going to do my best to make a pentagon. About 6, about right there. Let's see. Close enough. All right. All right. So then we're given the center of somewhere about right there. Then you're given most of what you need. Now you remember where it's not, may not be drawn like a regular polygon, but where it's supposed to be a regular polygon. So that means the distance from the center here to these two vertices is the same. These sides are congruent. Some of the other information you are provided here, they give you they label the apothem, but you do not have its value. They just label it A. And they tell you that this angle right here is 36. Now, if you don't remember, if the angle's not given, if all you're given is the side length, and then the figure, how do we get this angle? Remember, the polygon can be divided into congruent triangles. If we connect the center to that vertex here, let's jump over that number there, like that. If it's a pentagon, there are 5 sides, so it can be broken up into 5 congruent triangles. Therefore, all these angles at the top here that meet at the center, those are all congruent. So take 360 divided by the number of sides, and now you know what this angle should be. But then we have to divide it again, since the apothem bisects that vertex angle, 72 divided by 2. So that's where they got that 36. Okay, keep that in mind. Okay, so 36. And the last piece of information we're given here is that this distance is 4 inches in length. So let's find the perimeter first. That'll be a lot easier. Once again, isosceles triangle right here. Vertex angle right here. So then that means this is the base. And the base is bisected. So if this distance is 4, the whole thing must be 8. It's a pentagon, so there are 5 sides. So the perimeter, 8 inches times 5 sides, so 40 inches around. Now that we have the perimeter, we'll be able to find the area, since the area is, we're one step closer, 1/2 the apothem times the perimeter. So check. Now we just need the apothem. So let's isolate that triangle. Gonna need our trigonometric ratios. So use this space right here. Right angle. Forgot to label it. So we know this distance is 4 inches in length. This angle is 36, and we need our apothem. Remember, in the previous example that I covered, for this type of problem, we use tangent. You will always use tangent. Alright, because this side over here, this one is the same as this one. So let's put the tick mark just to indicate that these are supposed to be the same. That's your hypotenuse for this right triangle. If it's not given, we don't need it, we don't want it, we don't care. So I just gotta find, we have this side over here, which is opposite from the 36 degrees. This is the adjacent side, so we must use tangent. So tangent of 36 is equal to opposite over adjacent is equal to 4 over A. We use our little swapping trick, since the variable's in the denominator. So the apothem A is therefore equal to 4 divided by tangent of 36. Type that into the calculator. 4 divided by 36 tangent equals 5.505527682. Since the formula calls for multiplication, so now that we have our A, and you can just take that number, multiply it by the perimeter, 40, and then divide it by 2. So 5.50 times, so let's write it out. 1/2, let's write it out just for the sake of it, why not? Times 40. So take this number, multiply it by 40. We get this nonsense. 220.2211073. Divide that by 2. Now we can round. Get 110.1105536. Which is approximately 110.1 yard. Does it make a difference? Well, let's find out. Let's say we round from the get-go to the nearest tenth, 5.5. So instead of using the whole thing, we're only going to use 5.5. 1/2 is 5.5 times 40. Why am I doing this? Well, I think it's helpful to see, how this stuff affects, how these little changes can affect the outcome. So see, this time 5.5 times 40 gives us exactly 220. We divide that by 2, well, we get exactly 110. Now 0.1, that's a pretty negligible amount, but still, can still make the difference between full credit and partial credit. Yeah, I know that's not fair, but you may think it's not fair, but it's about directions. Like I said, I'm working on a little leniency. All right, and the last one has to. So we're going to leave it at that one. I'm not going to cover number 6 because that's a circle. And we've already reviewed a circle in the previous video. Only difference here is that in this page you're given the radius instead of the diameter. Okay? So everyone should be able to work that one out. So we're going to call it here. You have 3 remaining pages of examples. The solutions are already provided there. It's just a matter of working them out, using those as practice. And then moving on to the assignment. All right, so that concludes the presentation.